Every year at National Math Counts, I meet fantastic people. About a decade ago, I met the Monks family because one of them was participating. Now we're coming a decade later, and the Monks family, whole family of mathematicians, sharing their knowledge with the Prove It Math Academy, which not only has some really nice math, it's got some nice threads too. Now, in a really good proof, really magical proof, you look at it and you think, wow, it must just popped into the head of somebody. That's deceiving. That's deceiving because that beautiful proof hides a really powerful problem-solving strategy. We're going to look at that strategy today. It's simply get in there and mess around, see what you can find. We're going to try that right here on this problem. What four-digit number has tens digit 2, units digit 8? It's a multiple of 16. And then when you reverse the digits, you also have a multiple of 16. Now, it's kind of hard for us to mess around with these words, so we're going to throw in some variables here. We're going to call the thousands digit A, and we're going to call the hundreds digit B, and we know the tens digit is 2, and the units digit is 8. Now, I don't have a magic formula for this, so we're going to have to play with it. We're going to have to explore. Now, I could explore by trying to find a bunch of multiples of 16 that end in 2, 8. That sounds kind of hard, and there could be a whole lot of them. But you know, whenever I get stuck on a problem, I look back at the problem, look for information that I haven't used yet. So we're going to try that here. Digits reversed, result is a multiple of 16. So we're going to reverse these digits. We're going to get 8, 2, B, A. And that's a multiple of 16, and that's easier for me to think about because, you know, I know there's only 100 of these numbers, and I know where they are, right? They're nice and in order from 8200 up to 8299. There can't be that many of them that are multiples of 16, so I can just find those, test them out. But now to find those multiples of 16, one thing I could do is divide 16 and that, use some long division, but life's too short for that. I'm going to be strategically lazy. All right, I'm going to start with the observation that 8,000, that's 8 times 1,000. 1,000 is even, 8 is 8. You multiply those two together, you get a multiple of 16. 8,000 is a multiple of 16. 160 is also a multiple of 16. Add two multiples of 16, you get another one. So 8160, that's a multiple of 16 as well. So I can just keep adding 16s onto this. I get 8176, 8192. Add on 16 more, I get 8208. Now I can just keep on adding 16s and I'll pound out my multiples of 16 to start 82. So let's do that. I get 8224. 8240, 8256, 8272, 8288. Add 16 more on, I'm past 8300. So these are the only candidates for the number I get when I flip the digits, and I have to remember that. I'm looking for the original number. These are the numbers I get after I flip it, all right? So now I have to figure out, well, these are all multiples of 16. Where did these come from? How did I get these numbers? Well, I flipped the original number. Let's look at what happens here. In order to get this number, when we flip the digits, I had to start with this, 8,028. Is that a multiple of 16? Well, I know that 8,000 is a multiple of 16. I add 16, I get 8016. Add another 16, I go past 8028. I land on 8032. This is not a multiple of 16, so that one's out. I'm going to do the same thing here. Now, there's no magic here. We're just getting in there, getting our hands dirty. Now, is 4,228 a multiple of 16? I could divide 16 into that, but you know what I'm going to do. I'm going to be strategically lazy. 4,000, that's 4 times 1,000. 4,000, that's a multiple of 16. Add 160, that's also a multiple of 16. And we just do the same thing again that we did here. We just keep adding 16s. 4176. 4192, 4208, 4224, 4240. We jump right over 4228. So that one's a loser. Reverse the digits on this. We don't even have a 4-digit number, so we know this is a loser. It's also not a multiple of 16. That one's out. And this one we're going to flip back to what the number must have been before, 6528. Well, strategically lazy again, we're going to start off with 6,400 now. 64 is a multiple of 16, so 6,400 also a multiple of 16. Well, then I'm going to add on 128. Now that's a nice power of 2. The 64 doubled. 128 is a multiple of 16. I add 128 to that. lo and behold, I get 65/28. That's a multiple of 16. So now, very important, go back, read the question. What four-digit number? Blah, 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 blah. When its digits are reversed, also a multiple of 16. The question is asking for the original four-digit number. We want this one right here, 65/28. Got our hands a little dirty, found the answer. On to the next problem. Here we have the product of three consecutive integers is pretty large, and we want the sum of those integers. Well, first, to play around a little bit, we're going to go ahead and write an equation. Here's my product of three consecutive integers. And we know that this is 157,410. Now, I could multiply this out, right? I can multiply this all out. That's going to give me a cubic. It's going to give me a mess, something I really don't want to play with. I can play with this because I know something important here. I know our answers here are integers, so maybe I can just guess and get lucky. Now this number here, when we multiply that out, it's going to be real close to n cubed, so that can kind of help me zero in on my guess. 10 cubed is 1,000, 100 cubed is 1,000,000, so our answer is somewhere between 10 and 100. I'm going to go right in the middle. I'm going to go with 50, because I know that 5 cubed is 125. All right, so 50 cubed is pretty close. It's pretty close, because it's 5 cubed is 125, so 50 cubed is 125,000. It's a little too low, n's probably a bit bigger than 50. So let's check 60. Natural thing to try next. 6 cubed, 216, so 60 cubed is 216,000. So my answer is between these two. All right, my answer is somewhere between 50 and 60, because this is well between these two. It's not real close to this. It's not real close to that. So n's probably not super close to 50 or 60. And then I see the zero sitting here, and I start to get really excited, right? Because that means this product is a multiple of 5. But n's probably far enough away from 50 and 60 that, none of these numbers is 50 or 60. It's telling me one of these is probably 55. Now, all I'm doing here is guessing. It's educated guessing. I'm guessing that one of these three numbers is 55. So now I start thinking, well, what about the other numbers? If one of the numbers is 55, then one of the others is going to be 54, going to be 56. Let's take a look at this over here. And I'm thinking about 54. I'm thinking about 56. And I look at this number and I think, that's not a multiple of 4. Right? Because if I start with 157,400, it's a multiple of 100, so it's a multiple of 4. But then I add on 10. 10's not a multiple of 4. That tells me that sum, 157,410, not a multiple of 4. So I can't put a 56 in here. There's no 56 in there. So I've got a 55, I don't have a 56. This is what I believe. So these three numbers must be 53, 54, and 55. Now all I'm doing here is messing around and guessing a little bit. I have to go back and prove it now. I have to show that this product is indeed that right there. So we're going to do that. And again, I'm going to be strategically lazy because that's how I roll. I'm going to take a factor of 2 out of here, put it over there. Now I'm going to do that. Take a factor of 2 out of there, put it over there, because multiplying by 110 is really easy. I'm going to start with this product over here, 53 times 27. And let's see, I got 371. We got a 106. So that product is 1431. And I'm going to take that and multiply by 110. So first I'm just going to multiply it by 11. I like that. That's nice and easy. And sure enough, what do we get? We get 1, 5, 7, 4, 1. And when we multiply that by the 10, boom, we get the number we expected. So sure enough, we found it. We found it. But what's the answer to the problem? Once again, you always go back at the end. We want the sum of these three numbers. 53 plus 54 plus 55. Same thing as 3 times 54, which gives us 162. We messed around. We found the answer.